Naming things in code. Do you ever struggle to name things in your code? If so, you're not alone. Naming things is one of the hardest things in computer science, but it's also one of the most important. In this video, we'll discuss some bad naming practices to avoid. We'll also talk about how to name things effectively so that your code is easier to read and change. Navigating the intricacies of computer science presents two formidable challenges: cache invalidation and the delicate art of naming elements. While these challenges are notoriously formidable, they remain conquerable with consistent practice and careful consideration. One of these challenges pertains to the fickle nature of cache invalidation, a technical phenomenon where cached data becomes outdated or irrelevant, leading to errors and inefficiencies. The second challenge, perhaps more subtly complex, involves the process of assigning meaningful names to variables, functions, classes, and other programming components. Mastering the skill of precise and intuitive naming is undeniably difficult, often leading to a gamut of errors and misinterpretations. Yet the paradox lies in the fact that despite its complexity, it is not an insurmountable task. By recognizing that poor naming can hinder comprehension and maintenance of code, developers can take deliberate steps to enhance their naming practices. The iterative process of trial and error, along with learning from established best practices, contributes to the evolution of this skill. Thus, while the challenges of cache invalidation and naming might be formidable, they offer fertile ground for growth and mastery, making them integral components of the dynamic landscape of computer science. The age-old maximum of avoiding naming variables with a single letter remains a steadfast rule in the realm of coding, resonating as a classic example of sound programming practice. This precept finds its roots in a historical context that intertwines the worlds of mathematics and computer science. Traditionally, mathematical notations favored brevity, leading to an emphasis on single-letter representations. This practice, however, doesn't translate seamlessly into modern coding, where the goal is clarity and comprehensibility. Single-letter variable names inherently lack the vital contextual information necessary for understanding the role and purpose of a variable within a codebase. Such names are a cryptic enigma to developers, leading to confusion and misinterpretation. Similarly, abbreviations, those once hailed for saving typing effort and screen space in the bygone era of limited technology, are now burdened by their reliance on context. Deciphering the meaning of an abbreviation with unfamiliar code becomes an arduous task, hampering collaboration and maintenance efforts. The landscape of coding has undergone a profound shift, propelled by advances in technology and coding practices. In today's coding environment, where screen real estate is ample and keyboard strokes are efficient, the advantages of single-letter names and abbreviations have waned. Modern coding values readability, maintainability, and teamwork. Therefore, adopting a comprehensive naming convention that eschews single-letter names and abbreviations has become a cornerstone of effective coding practices. As the coding landscape evolves, this steadfast principle stands as a testament to the ever-evolving nature of programming craftsmanship. The practice of embedding types within variable names, commonly known as Hungarian notation, has witnessed a decline in relevance with the emergence of modern programming languages. In this convention, types were prefixed to variable names, ostensibly to provide clarity about the nature of the variable. However, in contemporary coding landscapes, this practice has lost its footing due to the inherent nature of modern languages that embrace strong typing. Statically typed languages, where variable types are explicitly defined, advocate for a different principle. The type itself should encapsulate the variable's content, eliminating the need for type indications within variable names. This approach promotes clean, self-explanatory code and reduces the risk of misleading developers by implementing a type that doesn't match the actual variable content. Instead of focusing on types, a more effective practice is to include units in variable names, particularly when dealing with quantities or measurements. For instance, naming a variable delay seconds makes its purpose clear to both the user of a function and those modifying the code. Moreover, a more advanced strategy involves employing types like timespan or chrono duration in languages like C#, or C++. These types abstract away unit ambiguity, allowing developers to interact with time-based variables without getting bogged down by specific units. In short, as programming paradigms evolve and programming languages become more sophisticated, the necessity for Hungarian notation and embedding types in variable names diminishes. Instead, focusing on meaningful, self-descriptive variable names, coupled with utilizing appropriate types to eliminate ambiguity, serves as a testament to the adaptability and progressiveness of modern coding practices. A prevalent yet debated practice in software engineering involves the addition of types to types, often observed in the form of prefixing interfaces with I, like I something. This practice has been traditionally employed as a means to distinguish interfaces from classes, reflecting a sort of taxonomy in the naming. However, this practice is now undergoing scrutiny, as it may not align with the contemporary principles of clean code. Modern programming paradigms underscore the importance of intuitive and expressive code, emphasizing that code should read like well-structured prose. Prefixing interfaces with I can disrupt this flow, as consumers of the interface are primarily concerned with its functionality, not the underlying implementation. When using an interface, developers need to understand what actions it provides rather than its type. This practice also becomes problematic when attempting to refactor or change underlying implementations, as it necessitates updating the interface name, creating friction in code evolution. An illustrative example arises in the context of animating objects. Irrespective of whether an animation object is an interface, an abstract class, or a concrete class, the usage of that object for animation purposes remains unaffected. This reiterates that the prefixing of I for interfaces lacks a practical purpose in terms of code comprehension and usage. It's worth noting that even established .NET libraries follow the pattern of prefixing interfaces with I. While this might influence C+ code practices, it's essential to consider the broader context of code clarity and readability. In the evolving landscape of software development, prioritizing the intent and functionality of code over adhering to historical naming conventions emerges as a promising approach to fostering maintainable, cohesive, and expressive software systems. The art of naming classes and functions is a cornerstone of effective software development, embodying the principle that code should be self-explanatory and intuitive. One notable guideline in this realm is the avoidance of adding prefixes like base or abstract to class names. Such prefixes might have historical roots, but they can be more perplexing than clarifying in modern code bases. A vivid illustration lies in the naming of classes, where the use of base or abstract can mislead developers about the class's actual purpose. Consider the scenario of a truck class. When contemplating a parent class for it, appending base to truck doesn't enhance understanding. Instead, it hampers clarity and can cause confusion, as the name doesn't reflect the class's essence. Descriptive naming shines as the antidote to this naming complexity. Class and function names should mirror their functionalities and roles within the codebase. Rather than overcomplicating with prefixes, clear and evocative names should encapsulate the class's core function. If a class hierarchy demands differentiation, opting for specific, informative names can convey more meaningful information. By focusing on class and function names that succinctly convey their purpose, developers can contribute to a code base that is approachable, maintainable, and collaborative. Clarity is a currency in software development, and meaningful naming fosters a common language that transcends the immediate team, ensuring the software's longevity and adaptability. As the coding landscape continues to evolve, the timeless practice of thoughtful naming remains an enduring asset in the quest for well-crafted software. I hope this information will be handy, and don't forget to like, share, and subscribe to the channel. Meanwhile, thanks for watching.